In continuation with the previous video, in this video we'll start decimal representation of real numbers. So for this I have made a flow chart to make the concept clear and easy for you. Real numbers, as I said, is divided into or is the collection of rationals and irrationals. Rationals are further divided into terminating decimal and non-terminating and recurring decimal, recurring or repeating, one and the same thing. And irrational numbers are non-terminating and non-recurring decimals. Now, to make this concept more clear, I have taken some examples. Suppose I have taken 1 by 3. All of you know 1 by 3 is a rational number. If we divide 1 by 3, what do we get? We will get, just see what we'll get. We'll get 0.3, means this division is going on. When I divide this 1 by 3, again and again I am getting 3, 3, 3 in the quotient and 1 as the remainder. It means it goes on. It does not end. It does not end means the meaning is it is non-terminating. If we are not getting remainder 0, the meaning of this word is that the number is non-terminating. And what is the meaning of recurring or repeating? You can see easily that when I am dividing 1 by 3, I am getting 0.33 again and again. And the meaning of this dot is that it does not end. And we can write this as 0.3 bar. Bar means the number or the number of digits or the number which is repeating again and again. So what is repeating here? Only 3 is repeating again and again. That's why we have written 0.3 bar. Now one more example. If I divide this 2 by 5, I will get 0.4. So answer of this is 0.4. And here I am getting the remainder 0. Remainder 0 means I cannot divide it further. And the meaning of this is it is terminating. It terminates. So this is an example of terminating decimal. 2 by 5. It terminates. No dots, no bar, and remainder is 0. The meaning is this is terminating decimal. One more example I have taken. If you divide 1 by 11, then you will get 9. Again you will get 0.9, again 0.9 dot dot. So answer of this question is 0.09 bar. So the meaning of this is that again and again I am getting 1. The remainder here again is not 0. So which type of example, which type of decimal expansion it has? It has what? Non-terminating and repeating. I hope the concept is clear to you. If you divide 3 by 4, you will get 0.75. And this is an example of what? Terminating decimal. This is an example of what? Terminating decimal. And this is an example of what? Non-terminating and repeating. If you use the word repeating or recurring, both have the same meaning. Now, the example of irrational numbers, which I told you are non-terminating and non-recurring. So see some examples of irrational numbers. Root 2 is equal to 1.4142135662. So you can see that after the decimal there are so many digits and it goes on. These dots are telling us that this is going on, these numbers are going on, and if you observe it carefully you will see that nothing is repeating. No same digits are repeating again and again. In one other example, I have taken any example. Here you can see 0.12, then 122, then 1222, then 1222. Again, same block is not repeating. In this also you can see 3.60, same block is not repeating. So these numbers, which type of numbers these are? You can see non-terminating. Non-terminating means this dot is showing that it is non-terminating, it does not end. And non-repeating or non-recurring. Non-repeating means you can see easily no digit or no block of digit is repeating here. So these type of numbers are known as, which type of numbers these are? Irrational numbers. I hope rational and irrational numbers are clear to you. Pi is also irrational. Now the question comes in your mind that how pi is irrational, because when we calculate the area of circle or circumference of the circle, we take pi as 22/7, and 22/7 is a rational number. So when you will calculate, you can check it on your calculator also. When you divide 22/7, the number will be 3.141592, and the exact value of pi is this. So again it is non-terminating and non-repeating, that's why it is irrational number. But for the calculation purposes, we can take the value of pi, approximate value of pi as 22/7 or 3.14, as all of you know. There are some important points regarding this. First point is, there are infinitely many rational numbers between any two given rational numbers. You have done in your lower classes also that how many rational numbers are in between two given rational numbers. There are infinitely many, as well as there are infinitely many irrational numbers also in the given two rational numbers or irrational numbers. Second important point is, every real number is represented by a unique point on the number line, and every point on the number line represents a unique real number. Now we need to study the relation of rational and irrational numbers also, or you can say algebra of rational and irrationals. If I take R as rational and S as irrational, so addition of a rational and irrational gives an irrational number. Subtraction also gives us irrational number. If we multiply rational with irrational, or I should say R is a non-zero rational number. For these two particular cases, I should take R as a non-zero rational number. R should be a non-zero rational number. R is a rational number which is non-zero, means which is not equal to 0. If we multiply a rational number and irrational number, we will get irrational number. And if we divide a rational with irrational number, again we will get an irrational number. So you can say addition, subtraction of rational with irrational is irrational, and multiplication or quotient of a rational, non-zero rational with irrational is always irrational. Here are some examples. 2 is rational, root 3 is irrational. The whole is what? Whole is irrational. 4 is rational, root 2 is irrational. So whole is what? Again irrational. 5 is rational, root 7 is irrational. So product of these two is what? Irrational. 3 is rational, root 5 is irrational. So quotient of these two is what? Irrational. So I hope this concept is also clear to you. Now you need to do some homework, and the homework is that you need to do question number 1, 7 and 9 of exercise 1.3, question first of exercise 1.5 and example 12. All questions of homework you need to do in your fair notebook. That's all for this video. In the next video we'll continue.